Okay, I've drawn a graph here on the board. It's got asymptotes at 0, 2, and 4. It's got a point at 1, 3, and a point at 3, negative 3. And I want to try to come up with an equation of this form. Y equals C plus A times secant of B times the quantity x minus D. Okay. So basically I'm saying this is a transformation of secant. It's obviously just one period of that. And I want to try and figure out what all of these numbers are. Okay. If you want to try this on your own, you're more than welcome to pause the video, give it a shot, and then turn it back on to check your answer. This is the first time we're doing a transformation of secant, so if you want to just work through it together, that's a totally reasonable choice too. All right, so let's see. Let's do the horizontal stuff first. The horizontal stuff would be the stuff that I did before I plugged into secant. So if I look at this, I can see that the period is 4 minus 0 is 4. That's the difference between my ending point and my starting point. I like to write in that it's ending point minus starting point so that I don't make the mistake of assuming it's just the ending point, because not always am I going to have it that I'm starting at 0. Okay, but I know that the period is supposed to equal 2 pi divided by b, divided by whatever number I multiplied by here. So I can use that to solve for b. So I can say, okay, that's going to mean that 4b is equal to 2 pi. So divide both sides by 4. b is 2 pi over 4, or pi over 2. Okay. So I've got my b. Let's just keep track of that in this corner here as we work on things. So that's my new period. And I was able to see that pretty nicely. For the horizontal shift, which is what would be accomplished by this D, I need to see, are the asymptotes, have I shifted the asymptotes or not? So what I want to do is start by looking at what the basic graph of secant would look like. So 0 pi over 2 pi, 3 pi over 2, 2 pi. I'm just going to sketch y equals secant of x. Okay. I'm going to start with my nifty cosine graph. Whoops. Start with my nifty cosine graph. Okay. And of course, I would want to extend it so that I can start and end at an asymptote. Okay. And then I would flip the bumps. So this this low point of secant is what was originally at 0. It's easiest to see how I shift things if I take a look at where that gets moved to. And I can see that this low point actually got shifted over 1 unit to the right. Okay. So if that got shifted over 1 unit to the right, that means that my D is going to have to be, now let's see, is it going to be 1 or negative 1? I think it's going to be 1, because subtracting a number would make me think I'm moving to the left, but remember the horizontal shifts are counterintuitive. So subtracting a number actually moves things to the right. Now the reason I wanted to keep track of this point rather than where the asymptote was is because the location of the asymptote got affected by the multiplication by b. So here the asymptote would have been at negative pi over 2. Here the asymptote is at 0. I didn't shift things over by pi over 2 because I had multiplied by pi over 2. So to see how much the horizontal shifting is, I want to actually make sure that I'm looking at where the point where x is 0 gets moved to, because 0 isn't affected by multiplying by b. Okay. All right, so we've got our b and our d. So now I just want to take a look at my c and my a, which are going to be the vertical things. Okay. So if I take a look at what I have here, just looking at my y-axis here, 3 is the low point of these positive bumps, so that would have been the high point of cosine. Negative 3 is the high point of these negative bumps. Okay. Now, what's halfway in between that would actually be 0. So my middle value for cosine, the cosine graph would sort of be in between these bits, my middle value for cosine would actually still be 0. So that tells me that I have not moved things up or down at all. So my C is going to be 0. However, now instead of this vertical distance between center and high value for the cosine graph, instead of that being 1, that's 3. So we've stretched things by a factor of 3. So A is going to be 3. And it's positive because if you remember when I had my basic secant graph up here before, it did start with a positive bump and then a negative bump. So we haven't flipped it over at all. So I can say, okay, so y is equal to 0, which I don't need to write, plus 3 copies of secant times pi over 2 x minus 1. Now, I should mention that is not the only correct answer. Okay? I think that's the simplest, the most straightforward answer, but there are certainly lots and lots of things that we could have done differently. I could have, if I wanted to make my 3 a negative 3, I would have had to just shift things over more in order to make that match. So I think this is the most straightforward answer, but it is not unique. On quizzes and exams, I will accept any correct answer as long as your work justifies it. Okay. Now what I want to do is I want to do this problem again, but with one change. I'm going to change it to cosecant. Okay. I want to get this now as a transformation of the cosecant graph. Now, some of the numbers are going to be the same, but some of them are going to be a little bit different. So, let's take a look. If I look at my horizontal stuff, I can still see that the period is still just 4 minus 0, which is 4. And if that's 2 pi over b, then I can solve for b. And once again, I'm going to get that b was pi over 2. So that part hasn't changed. But D has. Okay. Because let's take a look. If I just graphed y equals cosecant of x, that I'm going to start by graphing sine as a helper curve. What am I doing? I'm doing it too quickly and plotting my points wrong. Okay, there we go. There's my sine as a helper curve. So I would have asymptotes at 0, pi, and 2 pi, and then I would flip the bumps. Okay. So I start with an asymptote at 0. We're starting with an asymptote at 0. Very nice. Very, very nice. That tells me that my D is 0. This time there is no horizontal shift. If I look at the vertical stuff, don't think that's going to be any different from what we had with secant, but let's just take a look at it just to confirm. Okay. What we have now is that the low value here that would correspond to the high value on the cosine, on the sine helper graph is 3. The low value is negative 3. And I can calculate that halfway in between those would be 0. So we have not shifted things up at all. C is equal to 0. Okay. But again, it looks like we have stretched by a factor of 3. So our A is going to be 3. And it is positive 3 because just like my basic graph for cosecant that I started with, we start with a positive bump and then go to a negative bump. So I could say this is y equals 0 plus 3 cosecant of pi over 2 times x minus 0, so I don't need to even write that in. So this is another equation for exactly the same graph. I mentioned last time that there were multiple answers if I wrote it in terms of secant. Same is true if I write it in terms of cosecant. Again, I think this is the most straightforward of them.